All right, so today I want to talk a little bit about navigating the Density app. If you're able to locate the link and use that, you're able to see some of the cool things that it's able to do. But basically, when you're looking at density, you're looking at a comparison between the mass of an object and its volume. And you notice in this particular setup, you have kind of this beaker that contains liquid water. You also have a scale that's located nearby. And so the method of acquisition of volume that's going to be used is we're going to be using water displacement method. That's where you look at the amount of water that rises as a result of adding a specific object. And depending on which object you have, that object is either going to sink down to the bottom or you're going to have to submerge it to get the volume that it pertains to. So for instance, if I take a piece of iron, you notice that when I added this iron object, the water level actually rose. Whereas if I took another object and said that was gold, it rose to about 27.6. Now, of course, if you wanted to compare it, you'd want to take the object out so you'd be able to compare it to that initial volume and you'd see the growth when you add that object. You can do that with iron here, you add that. You can do that with lead as well. If you take the lead out, you add it, the volume level rises. Some of the little or lesser known ones are going to be the objects that tend to have a little bit of a buoyancy or floating behavior. That might be seen when you're dealing with rubber. Notice how the rubber kind of sits on top. If you want to really find the volume of it, you'd really have to kind of push it in there and record the volume. Same thing with if you had foam, you had the foam and seeing that it's not that dense, you'd see that you have to submerge the foam in there in order to measure the volume displaced. Now, to find the volume displaced of an object, I want to recap that. Let's say it's 25.5 initially. When I add the object, it rises to 31.9. I would just simply take the difference of that, and that would give me my volume in milliliters. Now, if you want to find the density, you got to get the mass. So we've gotten the volume, and then the other thing you have to do is be able to put these guys on an object. So you take this mass of 72.32, and then you'd end up finding the quotient or the product of the answer when you take 72.32 and divide that by the volume of water displaced. Not 31.9, but actually the difference between 31.9 and 25.5. So you want to be mindful of that when you are trying to find your density. So now what I want to do is I want to take a look at an object that's made of wood. So here I have an object that's made of wood. It's 1.95. And I'm going to take the object and I'm going to add it to my beaker containing water. Now, when I add the object to the surface of water, you notice that it really doesn't submerge that much into the water. It tends to almost float. So here's what I'm going to do. In order to get an effective displacement value or amount of water that gets removed or added rather as a result, I'm going to take the wood and submerge it. And you notice that it goes from 25.5 and that number rises to about 28.5. And so anytime you're adding your water, anytime you're adding an object, is going to displace your volume. Now, if you have a larger volume of that metal object, it's going to result in a larger amount of water displaced. So that's kind of how that works. So when you're looking at trying to find density, you got to know, how much water gets displaced or moved in order to understand your volume. Now, the cool thing about density in general is density can be used to identify an object. It can kind of tell you what's going on with that object, and you can look at that as a feature. Now, not all wood pieces would have the same density, and you can actually look at different wood pieces to kind of understand how they're different. But in this case, if we're looking at different objects, they're going to have different densities. Now, what does that mean? Well, if I took this piece of wood, and let's say I increased the mass of it. Well, if I increase the mass of it, I have to also increase the volume. If the volume increases, I'm going to therefore increase the amount of material that gets displaced. So let's say that you have an object where you have a situation where the volume that gets displaced is greater, but your mass stays the same. But if your mass stays the same and the volume that you displace increases, that's going to impact your density. So you want to think about that when you're going through kind of comparing them. So let's say all objects were the same mass. Well, they're not going to displace the same volume because they have different densities. So that's just kind of a little nugget of wisdom that'll be pretty helpful in looking at density.